using a regular computer, breaking common codes might take, and I've heard 9 billion years and I've heard 90 million years, but it doesn't really matter because,
Yeah,
you know,
forever.
yeah, close enough to forever, and who'd care after the first 9 million
Yeah.
years?
Welcome to Tech Times. My name is Ryan Epps, and I'm here with Lawrence Gasman, the founder of Inside Quantum Technology Research. Now, you guys recently had a paper published in April, I believe, is the latest one for annual global analysis. Is that correct?
Not that I'm aware.
Oh, oh no. Oh well, I guess. but but we are here to talk about quantum technology, correct?
Yes, indeed.
Awesome.
I got that right. Yep.
Awesome. Now, just to start things off, just to kind of softball and kind of get into the weeds here, but
Mhm.
something really simple. What would be the difference between a supercomputer and a quantum computer?
Well, actually, um, from an application standpoint, they're used in very similar circumstances. The people who are buying quantum computers now or access to quantum computers are exactly the same people who would have been buying a supercomputer, access to supercomputers. So they're very similar things. What
Yeah.
differs is how they actually work. So a supercomputer works exactly the same way as your iPhone works. Um,
Interesting.
uh, but it's designed to deal with very hard problems. And
Mhm.
I don't know how much you paid for your iPhone, but a supercomputer can easily cost several $1 million.
Oh, for sure.
So there are differences. Um, and I, even though theoretically an iPhone can calculate what a supercomputer does, I would have no idea how you would do that. Um, the difference with a quantum computer is it's fundamentally different in the way
Yeah.
that we use, as I'm sure you know, in a regular computer or an iPhone, bits, ones and zeros. In a quantum computer, we use something called quantum bits, qubits,
Yep.
which, and I don't think it's useful to go into the details of what that really means,
Mhm.
but it's in the nature of qubits, because they're inherently quantum, to do a lot of things at the same time, which means you can process a lot more information in any given amount of time, which
Interesting.
means that and I'll give the example that, because it's really dramatic, not because it's the only example, that quantum computers can break most, well, they can't yet, but they clearly will soon be able to break most um, encryption that's used
Whoa.
in, in everything really. The the basic paradigm for encryption in commercial applications and in some government applications has served us well for 40 years, but
Wow.
any encryption will be ultimately broken.
So not
And
yet.
but and it depends who you talk to, but the time frame for when that will happen is getting closer and closer and
For sure.
closer. I think about 3 years.
Wow.
Um,
Okay.
but you'll certainly can find people who are going to tell you a lot longer than that.
Yeah. Yeah.
And as a footnote, remember, um, the inclination is to think about breaking codes in real time. If you go
Yep.
back to the Second World War and the Enigma stuff, they broke the German codes overnight so that the Allied shipping could be safe from German U-boats and
Yep.
the next day. But if you're trying to steal the plans of an aircraft and it takes you a lot of work and you don't actually break it for 6 months, well, consider that the B-52, by the time it goes out of commission, will have served for 100 years.
Yeah.
But the big thing is really you could break common encryption codes with, well, again, with your iPhone if you're insane.
Yeah,
But I mean, with a supercomputer, definitely.
yeah,
And soon with a quantum computer with enough, qubits capacity.
interesting.
The difference is, and you hear different numbers, but the point is still the same. The using a regular computer, breaking common codes might take, and I've heard 9 billion years and I've heard 90 million years, but it doesn't really matter because,
Yeah, forever.
yeah, close enough to forever, and who'd care after the first 9 million
Yeah.
years. But that's using a regular computer, including a supercomputer.
Oh, wow.
But
Okay.
and again, you hear different numbers about quantum computers, and nobody really knows, honestly. But 9 hours might be more
Wow.
like it, and that means that that means there's some very, like, you want to break all the encryption on my emails, go for it. You'll find that my wife asked me to bring home a cauliflower from the store. Shocking news. But, obviously there are more important things than the Gasman's cauliflower. So, that changes a lot of things. And there are ways to protect against breaking with quantum, and that's a whole new field, which is, one of the most important fields commercially, is protecting things from quantum computers, because it is getting near. So, I mean, that's what is different. Quantum computers look to algorithms that are very hard to solve in any serious way by any other way of doing it, and we can talk about other examples. Although they're a bit dull, the actual examples, they're just important in practicality. It's not an alternative to a regular computer. So, for instance, there are different ways of building a regular computer. You could build them with optics, for instance. Never been done very well, but or molecules, but it would still be a classical computer that would do similar things, and might be cheaper or more expensive or faster or not. This is something very different. And, there are plenty of, and this is important because I've seen the opposite stated by important people. There is never going to be a time when we replace regular computers with quantum computers, because there's some things quantum computers are really bad at. The classic one that's mentioned, and it sounds weird, but it's true. A lot of quantum computers can't actually add 1 and 1 and get 2.
Really?
And my answer to that is, well, try a 5-year-old. They should be able to do that. And I mean, there's some interesting philosophical problems that follow from that, but you probably don't want to discuss those. So that's what a quantum computer is. There's ways at this point. There's numerous ways of building them. We're at a very early stage. There's a few companies that clearly have them available now.
Like IBM, I think, is probably the biggest.
Well, IBM is by far the biggest name and by far the furthest along. They use a particular kind of technology. They use a superconducting technology, which means you've got to freeze. I mean, you don't have to freeze anything. You have to cool it down to incredibly low temperatures. And by the way, that's if that's the way you do it, then that's another reason why we probably aren't going to have quantum computers, on our desk anytime soon. The fridge is about $1 million.
Oh, what?
And I don't know what I don't know what your fridge cost. Mine was expensive enough. It was like $4,000, but not $1 million. And there's a small group of companies that have made a business out of that. But you're right.
clearly the
Well,
buy-in is very, that's a lot. That's a hard investment just for, as you said, just the cooling alone is 1 million.
and that's for
The
the
technology.
superconductor. So
Yeah.
there's another approach that's being taken by a company called Quantinuum, which is basically Honeywell, and also by a company, public company called IonQ, that's called trapped ions. You don't need to cool stuff down as far. The cooling doesn't cost anywhere near as much. And so now they're talking about um, uh, a quantum computer in a data center.
Yeah.
So if you're looking
Hmm.
at, I don't know, I can't think of Ford, which has huge data centers, or
Yeah.
one of the the service providers, Apple. They may at some point in the future want to buy a quantum computer for whatever. I can't actually think of an application, but you can assume they will.
Yeah.
And a trapped ion might be the way to go because it's going to cost a tenth of what an IBM machine costs.
Yeah.
But people do buy IBM machines as well as leasing time on them, and it's a mixed bag of all the different things you can do. But one on your desk is unlikely, although you can buy from a Chinese company one for I think $5,000, but it doesn't do much, and it's
Yeah.
it's it's for the kid who has everything.
That's kind of
Except
cool though.
except he wouldn't have a quantum computer, not really, because he
Yeah.
couldn't do anything with it. But
And what, so going off of that,
Mhm.
now we're seeing this huge um AI has become this huge concept in the space, right? The zeitgeist, the cultural zeitgeist is that's all they talk about nowadays, artificial intelligence.
Yep, yep.
Can you tell me how if there is much of a difference between quantum technologies and artificial intelligence and how they might be able to help each other or how they might even be able to, I don't know, one might be better than the other.
So there's no actual connection between the two
Yeah.
whatsoever. One is a very rapid processing technology that gets through 90 million years of work in 9 hours.
Yeah.
Again, you're welcome to quote me on those numbers, or someone will give you completely different numbers. Artificial intelligence is essentially a way of mimicking the brain, um, and it's a software technology.
Yeah.
Now, the two have been mentioned in the same context, in the same breath, for very many years.
Yeah.
For what it's worth, which is probably nothing, when I was thinking about what to do with my PhD thesis, where to go and all that. So we're talking about 1970, right? It's a long time ago.
Yeah.
And I didn't do that. I did something else. But I was thinking of artificial intelligence, and it's been around a while.
Oh yeah.
And
Oh yeah.
the only place you could do it in Europe, which is where I grew up, was at University of Edinburgh, which was
Oh
cold,
well.
which was another reason I didn't want to go. But I mean, I did learn a lot in preparation for interviews and things like that. And as far as I can see, and there was another surge in the 80s, which I
Yeah.
followed. Artificial intelligence has not gone that far conceptually.
Mhm.
I mean, there's been non-revolutionary developments in artificial intelligence and new directions and cleverer. What has changed big time is the processes you run it on.
Mhm.
So now AI is always connected with NVIDIA because they've got very fast processors, which come from their gaming thing. And you can also run it on quantum processors, producing something pretty horrifying. So I hate to go back to the encryption thing again,
Yeah.
because and nobody knows the answer. But if a quantum processor, a quantum computer is actually pretty darn dull. It isn't any more interesting than your eye. I mean, it's interesting because it exists, but in terms of what's going on inside. So combine it as you suggested, and you have an amazingly powerful tool.
Wow.
Nobody knows quite how powerful. What I can tell you is that AI in quantum is becoming a thing.
Of course.
And we will have, I mentioned to you, and I think it may be before we came on air, that we're doing we do, I think, 4 quantum conferences um, a year around Europe and the US.
Yeah.
And I wanted to do a panel 5 years ago on AI and quantum, and I couldn't actually find anybody who wanted to talk to it or talk to that topic. So I wrote a paper and gave it instead, and probably everybody except me has forgotten I gave it. But this year we have a keynote by a well-known journalist on just that topic, and we have 2 of the leading lights of quantum and AI talking about it
Awesome.
and talking to each other about it. So
That's
we've
exciting.
got Shiva Assad, who invented quantum encryption, and we haven't really talked about that yet. And
Yeah.
he happens to be in Montreal at his own think tank. And a
Wow.
guy called Joshua Bengio, who's also based in, actually, Gilles isn't at his own think tank. It's Joshua who's at his own think tank, and Gilles is at University of Montreal or something. I should know, but I've forgotten. And they're going to talk to each other about just what you asked me, and the fact
Yeah.
that 2 really big names, one in quantum and one in AI, think it's actually worth talking to. I mean, they know each other
Yeah.
quite well, but the people that they can talk about this topic in public means that something big is happening.
Yeah.
But it's at a very early stage yet.
I'm curious, why hasn't it been such a concept before? I mean, you mentioned you're one of the few people bringing it up 5 years ago. Why hasn't anyone considered
Well,
it?
5 years. Well, no, I think they have. I mean, I'm
Yeah.
not that clever, because you said it first of all, which is it's obvious that they go together. If it's a processor speed, so I think, I mean, probably back in 1970 when I was considering my PhD at Edinburgh, somebody could have asked, well, when we get processors fast enough, surely this will have some dramatic results.
Yeah.
So I don't remember, it's a long time ago, 50 years, that people were asking those questions, but it would have been very easy to ask those questions. In fact, it may have come up because that was around about the time that people were talking about integrated circuits and things, but they were just beginning to happen. So it was an obvious question then, but nobody would have said, yeah, it's going to happen. I mean, they might have said it, but it won't happen for another 50 years, and it didn't. So that's why it hasn't come up. And as to 5 years ago, well, quantum machines, quantum computers were still, I mean, they still are very primitive. But they've come an enormous way in 5 years. It was still possible 5 years ago to say that quantum computers could not be built. Well, quantum computers beyond a certain power could not be built, and it was without getting laughed at. And there were important people who said that. Now you really can't say that. You could say, but nobody really is, that they couldn't be more powerful than a certain amount. So you've got those, and they're treated seriously. And all I was doing in my paper was kind of speculating about things that you might get out of that. And I think that at this point, if I'm writing the paper again, it would consist of saying, well, we don't really know because the potential is huge. And then if you take that conversation much further, you wind up talking not about engineering or computer science, but really about philosophy and AI. And happy to talk about that. But
it's like as I said earlier, it's the cultural zeitgeist now. Everyone's talking about it, and it's being put into almost everything. Everything from Slack to sneakers. Like everybody's using it, and it's a little scary. What are your thoughts just overall on just how far we've come now with AI? I know you said earlier that it's like, it's
well,
not
again,
there.
remember, I'm not an expert on AI. I've
Yes,
just followed it over a long time,
for sure.
and I got the opportunity to talk about it in the context of quantum because I gave myself the task.
Yeah.
So, I don't know. I've got a colleague who's very keen on an AI. He is not a technical person. He's a
Yeah.
marketing person. So he's looking at, Chat GPT and other things as a way of enhancing. So he rewrote something I'd written, a report I'd written, actually a promotional thing for a report I'd written. And the funny thing was he didn't tell me he'd used I don't know if it's Chat GPT specifically, but that kind of thing. And
Yeah.
I knew instantly it was an AI, partly because it used a word that he never would have used. I mean, not
Yeah.
a bad word, just a forgot what
No,
it
yeah.
was, but it was a rather highfalutin word, and it's just not what he would have used.
Yeah.
And that's not that important. It's just because I've known Rob for 30 years. But the other thing was there was a sentence in the middle of it which was utter nonsense and couldn't have been written for by a human being unless there's something seriously wrong with his brain, which is essentially what I'm saying was wrong. So we've got a ways to go.
Yeah.
I'd also say, and I've heard Yoshua Benjo say this on an interview, it can do a lot of things that a human can't. But then a hammer can do a lot of things. I mean, you ever try to knock a nail in with your fist? Not a good idea. An AI positioned correctly, installed correctly, could read every book that's ever been digitized, which is pretty much every book at this point that's worth knowing about, and do it in, I have no idea.
A couple seconds, probably.
Yeah. Well, yeah.
Yeah.
Well, it would depend on what it was running on, but let's say it was running on a quantum computer, then probably.
Wow.
Who knows? And again, kind of who cares? Because it's not a competition.
Yeah.
Because there's no human being ever been born that could do that. The question when it comes about whether it can really make judgments, and whether it's programmed to make judgments that might be, kind of detrimental to human beings. So you get the Terminator
Skynet.
Skynet.
Yeah.
And it decides that whatever I don't think we ever know quite what it was supposed to do, but it maybe we do, but it's programmed to do something, and it thinks that eliminating human beings is the way to do it.
Yeah.
Well, first of all, Isaac Asimov thought about this a long time ago. You just program
one of my favorite writers. Yeah.
Yeah. Not mine, but I mean, clearly he has some interesting ideas. And you could program it to not do things like that. And somebody could interfere with it and make it do that, and you'd have to ask why they would do that. For instance, there's a number of countries that have nuclear weapons now who might decide to go to war with the United States. Iran's probably the most obvious example with ideology that might allow them to do that, but they haven't, and there's not much sign that they are really. So I can imagine that we'd just be another danger that can kill us all. So I'm not too worried about that. But more importantly, I think, and we're getting onto dangerous philosophical ground now, that a lot of what we do has to do with the fact that we're conscious. And I promise you that as a quantum expert, they are not conscious. They are no more conscious than your iPhone. And you may think they're conscious, but they're still not. And and not being an AI expert, I can still tell you that they're not conscious. How we make, and this is what Bengio said in the talk I heard, and I bet you he says it at our conference, how we make a computer conscious is I mean, you and I are not, and the answer could very well be we can't, because we're a certain kind of thing and they're not, but not something you need to worry about or your children will need to worry about. We don't even really know what consciousness is. and so not that worried about it. And you can do some amazing things to model consciousness, but it's still not consciousness. So,
Interesting.
gee, I going back to the 60s,
Yeah.
that 70s actually, 60s, 70s. There was a PC application. I think it was called Eliza, and it was and it ran like on a really crappy machines that they had back then. And I had a TRS-80 back then, but it was a therapist.
Yeah.
And you asked it, will my girlfriend leave me, and what will I do if she leaves me? And it answers, and I had it. Everyone had it then.
Wow.
And it really was kind of convincing. If you didn't know, it was just a very low-level form of artificial intelligence. It wasn't conscious. It had no idea, and it's because, especially I imagine with therapists, they give, within a narrow range of answers. So I'm not too worried about anything really bad. Certainly not in my lifetime. I'm obviously a lot older, but I've got kids, so I do care whether they survive throughout their lives. So that's probably not a problem, and we've just got a long way to go before it even becomes a worry, except in science fiction books.
Yeah. Well, you had mentioned earlier, I mean, I think most people kind of missed this point, but you'd mentioned earlier the hammer, a tool. That's what AI is nowadays. It's just a tool. And I think a lot of people miss that, concept. It's because of the intelligence part of it, right? I think the intelligence makes people think, oh, it's like us, but not necessarily, right? Not at all, actually.
I mean, the ones that people talk about, and actually it occurs to me, Eliza, the one I mentioned, I think it was called Eliza, is manipulating language according to certain rules. And every time it sometimes screws up in ways that are obvious. I mean, I can't remember the sentence, but it was, if it had been written by a human being, you really wonder if they had brain damage. And because it was like someone, unfortunately, I've seen people who were in the last stages of dementia, and it was that kind of thing when they couldn't string words together, or when they did, they didn't make a lot of sense. So but I mean, I can see it being used in a lot of applications, and if it comes down market and runs, again, not quantum, but if quantum got inexpensive enough, which could happen, or it ran on like I have to stop advertising the video, but it does have to, but it's obviously the one company that everybody thinks about it. Stock price has tripled or something in the last year, and doubled actually, and they were lucky because they were in the right spot at the right time as far as AI goes. But they can do, quantum computers even now can do some fairly remarkable things.
For sure. Well, I'd love to talk. So what applications can quantum computers use now? So one of the reasons I reached out to Jake was talking about how how Moderna is using I forget the name of it, Pro-LM or something along those lines.
I think that pharmaceuticals and material development, which are the same thing, except one's used to kill people and animals and one's used for other things, are probably the application where things are already happening. Because you don't need I've just coined a phrase, a super quantum computer to do that. The reason they're so good at designing materials and pharma is that new materials is essentially a quantum problem. And what the quantum computers are doing are simulating different kinds of materials and then testing them out. And so, I mean, a quantum computer was literally built, they said, I was built for this. Well, quantum computers really were built for it. The problem, and this comes up in other areas too, is uh, it still needs to be tested.
Yeah.
So whether you've come up with a new coating for cars, or a way to ameliorate, the pain from cancer, just making those up. I don't think they're
Yeah.
particular examples. It still needs to be tried out, and I mean there are established tests. It would be interesting if new tests had to be devised, specifically things that came through, through uh, through quantum design,
Yeah.
and that hasn't happened. The second one is almost identical structurally, and well, a lot of pharma companies and some materials companies already have quantum teams, but so do the big banks and financial services.
Oh.
And um, it's hard to think of a really big bank that doesn't have a very highfalutin team of specialists in quantum now. And they have an amazing number of different things you can do with quantum. Some of them very small, but portfolio optimization is the one that often comes up. Trading, I mean, I'm a day trader, and
Yeah.
if I only knew how to program a quantum computer, I'm sure I'd do a lot better. I had access to one. In fact, there was some talk about that a couple of weeks ago on something I was reading. But the tests also apply. Like, we've got this really cool quantum computer driven portfolio that you can put your $1 billion into. Oh, whoops, we just lost you $50 million in 3 seconds. It didn't quite work. So they're going to have to try that out for a long time before well, I mean, they're either going to have to lie,
Yeah.
or they're going to have to convince someone that they're a trial customer and give them some guarantees or something. That all takes time, and the test, if you're talking about pharma, that's like a 2-year process, I believe. So,
Yeah.
but we're there to do something practical with both those examples, and we're almost there with a lot of the finance stuff. When
Okay.
you get to very complicated algorithms, especially in R&D and in some intelligence, in some transport applications, we're probably not that far away, and don't let anyone tell you it's so far off in the future that nobody should worry it. I mean, well, don't let anybody, unless they can give you a good reason for believing that. I've
Yeah.
always thought it was sooner rather than later. So there's just a lot of things out there, a lot going on in materials and pharma, a lot going on in finance. I can't, my
And
mind's gone a blank, but
how
there's at
exactly does
least.
that look? Like specifically for finance, how exactly do companies or banks, I should say specifically, how do they leverage quantum technologies? I know you're saying there's still kind of testing, it's still, but how does that look? Like tangible? How do they use the actual technology to benefit
So
their?
I'll give you a specific example, and it in a way it's one of the best. So there's a technique in statistical forecasting called Monte Carlo. Do you know what that is?
No.
So essentially, you run, you can run on a regular computer, and we've actually done it to value a company, for the company we were valuing, and you can do it on a PC with Excel,
Yeah,
and that's what we did. But
that takes
I
too
mean,
much time. Yeah.
well, yeah, but you don't want to run too many for that particular application, which was very important to the company. But you don't want to run too many. It's a simulation. You don't want to run too
Yeah.
many examples of that when you're running something very complicated, um, because essentially we were running it over a bunch of accounting data, which was
Yeah.
well understood. When you're doing it very under just unimaginable numbers of scenarios, a quantum computer is a perfect device. And to some ways, it's a bit like what I said about materials design and pharma design. They are inherently quantum systems. So running a quantum computer to simulate a quantum system is relatively a no-brainer. And this is kind of the same because a quantum computer, any kind of quantum computer, is almost like a giant. Somebody's going to kill me in the physics. It's almost like a giant Monte Carlo machine, because the way it works is actually to run through numerous simulations.
Okay.
So the reason it can break codes is because it can run through so many possibilities for keys. Again, oversimplification, whereas you can't. And so for a Monte Carlo simulation that's just very large, it's the perfect machine because that's what it does. That's also the reason why it never gets to 2 for 1 + 1. It's running through all the possibilities, and that's just one amongst many. And all it really cares is it gets to 1.9999999, and that's only absurd because we can do it in our heads.
Yeah. No, it's interesting. So I was curious how that works. And another question I had was so specifically when it comes to pharmaceutical companies work with IMB, right? IBM, I'm sorry.
Yeah.
How does that exactly work? Do they get their own system? Does IBM keep the system? How does that collaboration operate?
IBM has a few dozen systems out there, and in most cases, people timeshare. In fact, it's like where I came in, because when I was getting into computers and things, big serious business computers were all timeshared, and they were all IBM except for the ones that were Amdahl. And there is at least one company that seems to me, at least, trying to be Amdahl for the quantum age. But we'll get back to that. So most of them are doing that. I don't know if IBM still does this, but in the early days, if you were a serious student, even a serious high school student, you get a few seconds on an IBM computer for free. But because you had to know how to program it, and it's just as hard to program an IBM quantum computer now as it was back in those days, But it won't be. But it won't be. But there are a few buying their own machine. And the one that comes up is, it's a big healthcare, Cleveland Clinic. And I didn't really know what the Cleveland Clinic was, although I've been to Cleveland. It's a big medical facility, healthcare facility, but it also does a lot of R&D. And they just decided they wanted one of these things. And who knows whether they wanted it because they really want to do research or because that's really cool. And now we've all heard of the Cleveland Clinic. Probably a little bit of both, because IBM has this great video of them assembling the quantum computing. It's on IBM's website. Putting all the bits together when they brought it over there. I mean, the math of it, the economics of it isn't really any different from any lease or buy problem we've ever had. If you really want your technicians to sit there and do healthcare problems all day, then maybe that's the way to go. Most of the smaller companies, most of the small pharma companies are certainly going to go on leasing facilities because they have that kind of money. But increasingly the cost of quantum computers is going to come down, and eventually people will have that. And it depends on the problem. I don't think I said this, but when we were talking about trapped ions, they would be a lot less expensive, less cooling and all that, but it's actually slower than an IBM supercooled computer. And there's about, I did a a report on it, and there's about 30 different approaches to building a quantum computer, some of which have barely been tried, and they're going to find things that are, each way is going to have its own.
How complicated is it? I
Uh,
see. I built my own PC, and I must say, that people think that's you're so smart, but it's really not that
no, I
hard.
know. I've never built one, but I know I could.
It's yeah.
Well, um, it seemed well, no, I didn't actually, because I mean, how old are you?
20. I'll be 30 this year. I'll be
Yeah,
30
well,
this
I'm
year.
73, so I really do remember the beginning of personal computing,
Yeah.
and had a personal computer really early and email and things, but it was a Radio Shack machine. Well, no, they were amazing for what they
Yeah.
were. And not a topic for this talk, but looking back on it, they're absolutely amazing. I could have I didn't put it together, but I absolutely could. And I'm a
Yeah.
math major, not an engineering major. I think it, it's hard to imagine that you would be able to do that with a quantum computer,
Yeah.
even if um, even if the parts are readily available, which they're not. There's no way like Radio Shack then that you
Yeah.
can go and buy parts from. The only reason I was slightly stuttering over it is that, as I said, there's many ways to build a quantum computer. One of them is with optical components,
Yep.
and there's 3 or 4 companies doing that. And what I've been told is that most of the components that go into an optical quantum computing are stuff that's been developed for telecom and datacom optics, and you really could go and buy them. I don't know how really true that is, or whether so. I did actually a consulting job on microwave filters for quantum computers, and I know a fair amount of physics, and I know a lot about microwave filters. Well, these were subtly different. I mean, they really had to be very precise.
Yeah.
And
Yep.
I think the answer to your question is really I could put together the Radio Shack computer if I'd wanted to, because there weren't too many ways I could. I mean, as long as I knew what the CPU fitted to the storage or
Yeah.
something, and then you kind of snapped it in. But I could really screw things up on
Yeah.
a computer, and it just wouldn't work.
Yeah.
So 100 years from now, perhaps, and
Wow.
I don't know. I mean, if parts become standardized, so I mean, the first mainframe computers, if you exclude the one that they used to break the code for the Germans, from the Germans,
Yeah.
was probably the early 40s or something like that. And then 40 years later, I wasn't building my computer, but a lot of kids at the time were
Yeah.
building their computers. So 40 years is 2063. I don't anticipate being here, but you will be. So maybe.
Unless they put you in an AI, right? Unless they download you
Well,
into
and that's because the philosophical, and that's the
yeah.
philosophical thing is an AI replicant of replica of Lawrence Gasman, and I'd say no, but
Yeah.
but I know a lot of people would say yes to that. So building I mean, also money comes into it.
Well, also utility. I mean,
Yeah,
I built a PC because I needed a PC. It's not like I need
right.
a quantum computer. Not yet. I don't know. But
Well,
maybe.
what would you do? Well, you couldn't I mean, you seem like a clever guy. You could learn how to program it, but then what would you
Yeah.
do? I mean, it's for solving very complex algorithms. That's what it's really for.
Yeah.
And if you said I had a sudden jonesing for creating a new drug, perhaps you'd want to do that. But it just doesn't. I mean, it's that kind of thing, or a new material, and
Yeah.
uh, and then you could rent space on an IBM machine.
Now, do you see quantum technologies being used in the military or even aerospace? Like,
So it is used in aerospace. On the materials side, they're looking at aerospace coatings and things and looking at what would be most effective.
oh,
For instance, I'm trying to think. I think Rolls-Royce. Don't quote me on this, although this is a podcast, so I'm quoting myself. But I mean, quite a lot of companies are looking at coatings, for instance, to make
yeah,
them longer lasting and things, and you just try them out in the computer, which is a lot cheaper than painting a plane and flying it for a long
for
time.
sure.
I mean, at an operational cost level. Um, uh, so there's things like that in the military. It could also be used in the military for planning.
Yeah,
You know, uh, if you think about planning a major operation like the invasion of Iraq, I suppose, you know, it is run through computers. It's very complicated. You could write algorithms for it and possibly get a better answer. But
war
again,
games, right? War games from
war games, yeah. Um, so I've said this a number of times, and I suppose I should say that I have weak evidence for this, but it's not made up, that the intelligence community, well, I know the intelligence community already have quantum computers, and
for sure.
we'll have people talking about that at our conference in Montreal. And in fact, we've got InQtel coming to talk about that. I don't know if InQtel is a VC firm, but their entire raison d'etre is to get new technologies for the intelligence
Awesome.
community. And they're not going to tell me anything, you know, they have to sort of machine gun everybody in the room. But I would guess, based on what people have occasionally dropped hints to me, that they have and talk about US intelligence.
Yeah,
But
yeah,
don't be surprised if they're in other countries too,
for sure.
have some fairly sophisticated quantum computers that they play around with. What they play around with, I don't know. You know, it may just be coatings for the latest military aircraft, which is, you know, difficult to do, but not like, oh wow, kind of thing.
Yeah, yeah,
Or it may be tactical planning and things. You know, they're also very interested in breaking codes,
of
obviously.
course, of
Um,
course.
so, um, so uh, uh, it's the National Security Agency. Sorry, I can think of it from a moment.
That's
NSA
okay.
and GCHQ in UK, which is very much the same kind of thing, that
Yep.
are full of pronouncements on quantum, and you know, and particularly they're very interested in making sure that private contractors don't have things that are impervious to be broken, because
Yeah.
they think they want them broken. But they've also put out the story that we really don't have anything that cannot be broken by a quantum computer yet, and I'm
Hmm.
not entirely sure whether that's true or not. Um, I mean, their claims are true as far as it goes, but not sure if they'll be true forever by the nature of the
Yeah.
claim. We can talk about that if you want. But there's a long list of things, and I should have gone through them, but there were certainly the ones where, I mean, one other thing, Volkswagen, of all companies, had a project for navigating cars around big cities. And obviously that's directed
Mm.
to driverless cars.
Yeah.
Um, uh, and they modeled several cities, one of which was Beijing, I know, Shanghai, and you know, worked out how you could build things in a way that cars didn't smash into each other. And that's one of the things about driverless cars, is they're not. We've got a ways to go before they're
Oh
really
yeah.
safe. Yeah.
Oh, but I'm of the mind that, especially in my future, I feel like there won't be like I won't need to buy a car because there'll just be already services that drive people around already, if that makes sense, right?
Yeah. No, I
Like
think
an
that's right.
Uber, but driverless Uber essentially. I can
Yeah.
kind of see the world turning to that in some sense.
So I mean, here I am at my age, and I'm looking at my Toyota, which makes sure I don't go off into a different lane, and
Yeah.
will drive itself a little bit on a fairly straight lane. So it's pretty primitive. But we have got a long way to go. So I live in a town called Crozet, Virginia, which is just outside Charlottesville. And weirdly, we've got a driverless car software company here.
Mhm.
Because the guy who owns it, you grew up in Crozet, and anyway. So what they did, I don't know, maybe they're still doing it, was that during the day you could take a drive on their driverless car.
Like a test. That's cool.
But they did have someone in the driverless seat who could override it.
Of course.
And of course, I was like one of the first people to do this, and I was the only one in it at the time. So obviously, I interrogated the poor guy about all sorts of things he didn't know about. But anyway, we were driving out of the factory thing, and there was this lady walking up towards the factory, and he said, "Oh, well, we better stop and let her go by." And that's not the point. You're supposed to be able to, yeah. And I mean, what he was saying is, she probably would have been fine, but God forbid that she wasn't. And that's a reasonable thing to worry about at this stage. And obviously, these things aren't going on the road until you're 99.
Oh, yeah.
Yeah.
Oh, for sure. Yeah. All right. Going back to quantum technology, but the first thing that you mentioned was breaking codes, essentially encryption, which I know it's not for a while.
Right.
But what are some ways that quantum technology can be used in cybersecurity now to prevent such things? Like,
yeah, so there are basically three types of quantum cybersecurity, and they interact with each other in interesting ways, which is a separate topic. The two that are most quantum is one called a quantum random number generator. So a random number generator can be many, many different things, including a dice. You don't know whether it's going to turn up a pair of sixes or one and a five or something.
yeah,
Except that there are such things as loaded dice. And you may not care about that when you're playing something with your friends. Trust me, at the casino, they care. So the companies that make quantum random number generators actually have sold them to casinos. But if you think about it, they can be used in all sorts of contexts. So generating a key quantumly is something you can do. So there are some companies in Asia, some cell phone companies in Asia that actually have QRNGs, quantum random number generators, in their cell phones that generate keys, which mean that you're less likely to have your e-commerce transactions stolen. Now, that has not taken off. And if it takes off ever, then it will be by far the biggest application for for quantum, because how many I think it's like 3 billion cell phones.
Everybody has a phone now.
Yeah, and they don't keep them long. And the other one, which is essentially an identical application, would be for the Internet of Things, because there's a lot more things than there are people, and because the current security on IoT is just terrible. I mean, if you actually read about it, there really isn't any. So if they could use that.
Car security, right?
Yeah, and car security.
Oh.
And anything that's got sensors or little GPUs in it.
Gotcha.
That hasn't taken off yet, and I'm not sure if it's because QRNGs are still quite expensive, meaning they're a couple of bucks, but by the time it's gone up to you, and who's paying for that, and also, if you're putting things on credit cards, there may be crime, but you're not paying for that either. So it's probably something that will happen or get sorted out. So that's one thing, QRNGs. The other one that's very specifically quantum is quantum key distribution. And that means in public key distribution, you have a public key, but you also have a second key that's your own, but to distribute the public keys, well, you used to be able to just send it down a fiber optic network, because breaking into a fiber optic network was quite hard, if not, and seemed to be close to impossible. Now it's like, well, don't worry, we'll have it done in 3 seconds. We'll break it. So what they've done is transmission of the keys in quantum mode, which means if you try to interrupt that transmission, there is no key anymore. It's gone. And the thing about quantum random number generators is that quantum physics is the only thing we know that's fundamentally random. There's lots of things which come damn close to random but aren't random. So quantum key distribution, that's the one that GCHQ and NSA, and I happen to know the Russian security people don't like. And their claim, their claim is because at the moment it's over point-to-point networks. So if you over point-to-point lines, so if you try to build a network with it, you have to have something where it's broken from quantum to non-quantum and then back to quantum again. And that's the perfect place to, to break in and take the information you want. And I mean, at least in some places where they do that, there's armed guards outside. But again, that's not quite quantum. That's a little, heavy for, but there will be options, but there aren't options at the moment. The other way is actually really interesting because it's the one that will most immediately impact you. I mean, we've got software encryption and encryption chips based on public key encryption everywhere. I mean, it's in the browsers we're using now. And there's nothing quantum about that. But we've picked a technology that's incredibly easy for a quantum machine to break if it's powerful enough. And we're getting to powerful enough. And that's just one of those things. It's like, Y2K, we just programmed our machines in a certain way that happened to create a problem. It's a little like that. In fact, they call it Y2Q now, because if we pick something else, it might have been very hard to break by a quantum computer. I mean, quantum computers aren't gods. They work sometimes and don't work as well on other problems. So there's now a national, well, particularly national, because a lot of it's going through NIST, way of developing encryption programs that can be used. I mean, they're practical, but at the same time, it would be hard for a quantum machine to actually break them. And so there's no ultimate answer. I mean, there's a very nice introduction to encryption by a guy, I think he's from Oxford University, I'm not sure, called Singh. And he begins, on the first page, he said, well, there's never an encryption code that can't be broken or that won't be broken. And that's just the truth. And that's called post-quantum encryption, post-quantum cryptography. And there's a lot happening in that because that's kind of what you want everywhere. And now there's probably 20 or 30 companies actually producing software that does that and selling it now to corporations and to banks and the government but it's not, there's nothing quantum about it except in the minds of the engineers who designed it. And it's software, so two kids in the garage could actually do it, and somebody's going to make a lot of money from that, because you know how these things are. With software, it finally, it's like Word. You use Word? I bet you do. But there's a few people around who either use, you know, what's left of Word Perfect or something, or they use some weird nerdy thing that makes them feel good about themselves.
And one of the final questions I'll ask, it's something I feel like that was big maybe last year, right? The metaverse and stuff. But barring that, how or are there any companies using blockchain technologies with quantum computers at all? And how would that even look? I mean,
well, and also the metaverse. Let me answer that one. That my impression of virtual reality is it's always a bit
Yeah,
grainy, and I mean,
it's just
I,
not
I've
there.
been I've been following, yeah. I mean, and hasn't changed that much in quality. Well, if you used a quantum computer to drive it, it might be a bit more realistic. But
Wow.
especially if you're talking about graphics, not driven by photos.
Yeah.
As far as blockchain goes, blockchain is encrypted using some pretty standard encryption. So yes, it could be broken, and it could be broken by a quantum computer.
Wow.
I think with cryptocurrency right now, people are worried about other things like my
Yeah.
$1 million is only worth ten
I have
bucks.
a couple friends that bought NFTs that are worth nothing now, and it's
Yeah.
sad. I mean, it's sad, but what are you
Well,
gonna do?
I bought some, and
Really?
I almost no. I mean, well, I made some money on it, but got out. I mean, it was like
Yeah.
two weeks between when I bought it and sold it, and I didn't make a lot of the money, like $1,000 or something.
Yeah. It was a
It
good,
was a,
I don't know,
it was a bit of
4 month
a game.
period.
Yeah, it was a bit of a game, really. I mean,
Absolutely right.
if I'd lost my $1,000 or 2,000, I wouldn't be out in the streets. But yeah, it's like betting
Wow.
on a small company or something. Maybe
Yeah.
you're going to get real rich, and um,
And final question, and
mhm.
I think you kind of already brought it up before when we talked about cybersecurity, but like calculators on our phones, do you ever imagine in the future that we'll have quantum computing on our cell phones?
um, Gosh, I mean, I guess the answer is no.
Hmm.
Uh, and and the reason for thinking that is that it solves particular kinds of problems that most people aren't terribly interested in.
Yeah.
Um, so they need a machine to do it. But if some things are reformulated, maybe would use it. And the big thing I did bring up, but actually you brought up before, was AI. If
Yeah.
you want an AI machine and you want it on a very powerful processor, and you could afford the powerful processor. I mean, right now you're talking about maybe $10 million for a machine. I don't know if you're going to buy that $10 million iPhone, but
It's worth
say
it. It's
right,
worth it.
right. But say you had an AI machine that was really, really useful and maybe comforting and all sorts of other things, and it was $2,000 instead of $1,000, then maybe. But I don't think we even know how to make that yet.
Yeah.
I just before I came on, I was looking at actually a trapped iron machine, and what's inside is not a chip. It looked like a bunch of junk. Actually, it looked like they bought it at Lotus Electronics Hobbyist store, and maybe they did. They would have got it from a scientific store. Eventually, that will be a chip, and when it's a chip, you can put it in things.
Interesting.
So we're a long way off.
Yeah, yeah, yeah.
Um,
Awesome. Hmm.
yeah.
Oh, well, Lawrence, thanks so much for
No,
today. It was awesome.
thank you for
What
inviting me.
what if there's anything you wanted to go by all means add, do you want to add anything? Do you want to say anything?
No, I think, well, yes. I'd say that when I came into this 5 or 6 years ago, so I'd had a background in quantum mechanics, quantum physics going way back, and people have been talking about quantum computers for quite a while. And then I went to a lecture on new technologies of computing 30 years ago,
Yeah.
and they were 25 years ago, and they were talking about quantum computers. And it would never have occurred to me that this is something that's, real,
Wow.
or could be real. And then even 5 years ago when I started, there were a lot of naysayers who simply said we couldn't keep a qubit stable long enough to do anything interesting. I'd say that that's all gone away now, that we don't know that it can do all that it seems to potentially be able to do. We just don't know that. And maybe
Yeah.
there are, you know, limits to something somewhere. That would not be surprising in physics anyway. But clearly this is an industry that's growing. There's
Well, sure.
50 companies now producing either a full stack quantum computer or a QPU, the actual processor.
Yeah.
Won't be the first time that people have been very disappointed and lost a lot of money, but it doesn't look like that's happening. our first conference had 60 people at it. The one
Wow.
in Montreal will have 400. Um, uh,
It
you know,
is. Well,
maybe then
you were mentioning your next the next meeting you guys have in Montreal. When is
that
that?
will be that's the 20th through 23rd. If you go on our website, insidequantumtechnology.com, you'll find that we have 3 or 4 conferences. The most upcoming one actually is in Denmark
Okay.
in next month. The one in Montreal will be next month. And then the one after that will be our big one in New York.
Oh, awesome.
And then the one after that is our original European conference, which has actually been in Delft. Well, The Hague, actually, which is essentially the same place.
Yeah.
If there's any Dutch folks listening, I apologize for saying that. But I think it's going to be in Amsterdam next time. We don't really know. It could be in Delft again. It's just things we've been talking about, and that
Oh,
would be in March, I would say.
cool.
And that
We'll leave the links in the description, of course.
right, and we've got a events tab, and everything is at next year's ones are up there, for the 2 in June with all the speakers for New York. Probably
Awesome.
10% of the speakers, but I haven't got around
I,
to that one yet.
I'd love to go. I'll probably go to the New York one for sure.
Oh, well, right. Well, yeah, you're not very far away. Or get in
Yeah.
touch and we'll see what we can arrange. So,
Awesome. Thanks so much.
okay. Thank you very much again. I really
Yeah.
appreciate being on
Have a
on
nice
the,
weekend, Lawrence. Thanks so
yeah,
much.
thanks. Bye-bye.